Hello everyone, my name is Alexandria Glover and I'm going to be presenting on deriving the Michaelis equation for you today. So I'm just going to start off with a couple of quick things. So in this, E is equal to enzyme concentration, S is equal to substrate concentration, and P is equal to the product concentration, as well as K1 is equal to the rate towards step 1, K minus 1 is the rate backwards from step 1, and K2 is equal to the rate towards step 2. Okay, and that's gonna all make sense in just a second. So our first equation here that we're going to be working with is E, so enzyme concentration plus the substrate concentration in a reaction is equal to the enzyme substrate concentration. You'll notice here that we have two arrows going in both directions. That means that this is a reversible equation, hence the K1 and the K negative 1. So K1 when it is going towards, when it is consuming E plus S to make ES, and it is K minus 1 when it is consuming ES to make K, or it is ES being consumed to make E plus S. Sorry about that. And then we have a second equation here, ES K2 is equal to E plus P. So that enzyme substrate concentration that we made in that previous equation, moving forward through K2 is equal to the enzyme plus the product. Okay, so why this was important is because we're going to use this to, first we're going to solve for the ES, so the enzyme substrate concentration. We're going to use this formula here, DES dt. So that's enzyme substrate concentration over time is equal to K1, so that K1 value, E times S, so these two reactants here, minus K1, or K negative 1, sorry, ES. So that's what's being consumed each time. So E plus S was being consumed in K1 to make ES. ES is being consumed by K negative 1, minus K2 ES again. Because K2 again, ES is being consumed to make that E plus P. And this here is considered stable, so it is all equal to 0. Now what we're going to do from this is we're going to try to solve for E. We're going to do this first by kind of defining what that enzyme concentration means. So we're going to start with enzyme total. So ET is equal to enzyme total concentration is equal to the enzyme itself plus the enzyme substrate concentration. So what we're going to do is we're now going to isolate the E value here, and we're going to do that by subtracting the enzyme substrate concentration from both sides. So we have ET minus ES, and that gives us our E value. So now that is equal to the concentration for just the enzymes without substrate. This means that the E is equal to the total enzymes minus enzyme substrates. Now we're going to take this and we're going to plug it back into our previous equation. So DES T K1 enzyme total minus enzyme substrate. So again, we are plugging this value in for this E right here. That is times S. Negative 1 ES minus K2 ES. So because these are both enzyme substrate concentrations, they remain unchanged. So the only part that was changing was this first part here, and this is all still equal to 0. So now we're going to go ahead and distribute the K1 and the S that we're seeing here. So we're going to multiply both of these in to kind of just simplify this equation here. And what that's going to give us is K1 S minus K1 ES S minus K negative 1 still equal to 0. So again, the only part that changed was this part here became this kind of drawn out equation. And why did we did this? We did this so that we could solve for ES. We've now made it to where all of the ES's are separated, so that enzyme substrate value is now separate from all the other ones. So it is easier to kind of move everything around so that it can be isolated to find that specific value. So that's what I'm going to do now. So I'm going to take this equation and I'm going to start trying to isolate that all of the ones that involve ES. So I'm going to start by adding K1 ES S to both sides. That's going to give us now I'm just going to further isolate that ES equation, so plus K minus 1 ES plus K minus 1 ES, and that's now going to give us and again, I'm just going to take this last ES here and isolate that as well. So bringing it on over to the other side. Okay, so now I have all of our parts that involve ES here on one side, and here on the other side we have everything that doesn't include ES. So now I'm going to go ahead and I'm going to further isolate that ES. So I'm just going to pull out that kind of common denominator there, and I'm going to turn it into ES. So I'm pulling that out. That's K1 times S plus K minus 1 plus K2. So everything that ES was previously multiplied by, so K1 was multiplied by ES, S was multiplied by ES, K minus 1 was multiplied by ES, and K2 is multiplied by ES. I've kind of just pulled out that ES, so it's multiplied by all of them. The equation has not at all changed. I just made it easier to kind of look at it. And this is still going to be equal to K1 ET S. Okay, So this is our more simplified equation. So now what I'm going to do is, because I have it all simplified out like this, is I'm now going to isolate just the ES. So now because it is set up this way, I can divide both sides by K1S plus K minus 1 plus K2, K1S plus K minus 1 plus K2. And so what that gives us here is enzyme substrate is equal to K enzyme total, substrate total, K1 substrate plus K minus 1 plus K2. So that is now equal to ES. And I'm going to simplify this even further by getting rid of that kind of K1 value that we're seeing here reoccurring. So we have it on the top and the bottom. So I'm just going to multiply both sides by that reciprocal. So it's K, or 1 divided by K1 divided by 1 divided by K1. And so what that's going to do is that's going to get rid of all of our K1s here. So this K1 and this K1 are both going to disappear. And that's going to leave us with enzyme substrate is equal to our enzyme total substrate divided by substrate plus, and then because these two don't have K1 values in them, it's K minus 1 plus K2 over K1. So now what I'm going to do here is I'm going to substitute in, because that value that we just got right here, that is actually equal to the Michaelis constant. So what I'm going to plug in there, instead of having it K minus 1 plus K2 over K1, is I'm going to substitute it in as E enzyme total substrate concentration S plus Km. And this is equal to the enzyme substrate. Sorry about that. So just kind of marking where we've left off. Enzyme total substrate plus our constant is equal to ES. So that is where we currently are. And what we're going to do from here is we're going to solve for Vmax. So ultimately, that's what we're working towards. So we know that Vmax here is equal to our, oh, wait. Sorry, I'm actually getting way ahead of myself. So actually what we're going to solve for is the rate of change of the product. So that is equal to the product over time, which is actually equal to our velocity. And velocity is equal to K2, the concentration of ES. So now I'm going to use this to further plug into my previous equation. So I'm going to plug this value in for ES here. So E is equal to K2 E T S plus Km. So here we have that total velocity equation, and now we can use this velocity equation to solve for our final Michaelis equation. So starting with, of course, Vmax is equal to K2, which is also referred to as K cat, so it's our catalyst constant, times ET. So that is what Vmax is equal to. So again, here we have an opportunity to substitute. So velocity is equal to Vmax times substrate plus Km. And there we have it. We have derived our equation from our first one. Thank you.